Okay, so the first part of the 8-4 practice, hopefully this feels familiar, we're focusing on this triangle over here. And we want to do the same thing we did in the study guide. I want to get the sine, cosine, and tangent of L, sine, cosine, and tangent of M. So we'll start with angle L. Let's look from there. So we want the sine of angle L, okay? And we're going to base this on the picture that we have. And they're telling us here, to start with, that this is 15. That's the one side, that's the side that's opposite L. M is 36. That's here. And then N is 39. That's the hypotenuse. Okay. So remember the acronym, SOHCAHTOA. So if we want to start with the sine of angle L, then we have to position ourselves here at L, and we have to look at the hypotenuse, which is going to be 39. That'll be the same denominator for cosine. And then we look to the opposite side, which is 15. So that's going to be 15 over 39. I can divide both of those by 3, and I get 5/13. Okay? Cosine of angle L. So we're going to be in the same place. And again, remember cosine has the h in it, hypotenuse. So 39 has to live in the denominator there. Okay. At L, the adjacent side is now 36. So now we have 36 over 39. Again, let's divide both of those by 3, and we just have 12/13. And then finally, we want to take the tangent of L. That's the only one that doesn't use the hypotenuse. It's opposite over adjacent. So we look at L, what's adjacent to it? 36 is adjacent. So 36 lives in the denominator. 15 is the opposite. Let's divide both of those by 3, and we will see that we get 5/12. Okay, that's the first part. Now we're going to add a wrinkle to the algebra we can use here. So don't forget, we want sine, cosine, and tangent of M. Okay, so that's capital M. So sine of M is going to be the opposite over the hypotenuse. So now when we're at M, the opposite is now 36. And the hypotenuse is still 39. That hasn't changed. Right? We just fill these numbers in over here. 36 is here. 39 is here. And 15 is over here. Okay. So sine of M is going to be 36 over 39. Divide by 3, both of those, and we have 12/13. Now we want cosine of M. So again, 39 lives in the denominator. That's the hypotenuse. It's the adjacent over hypotenuse. So at M, now 15 is adjacent to it. So I have 15 over 39. Divide both of those by 3, and we have 5/13. Same numbers we got for L, we just switch them. And then tangent is going to be the reciprocal. Tangent of M will be the reciprocal of what we got when we did tangent of L. So at M, we want the opposite over the adjacent, so this time it'll be 36 over 15 instead of 15 over 36. Divide them both by 3, and we have 12/5 instead of 5/12 like we had previously. Okay, so the extra wrinkle that we're going to add now is to add some algebra to this. So I have this 64-degree angle up here. I want to use that. I have x, and I have 11. So if we look at where that angle is, we see that we want the side opposite, and we have the side adjacent. Opposite and adjacent, that means we're going to have to invite tangent to the party. So let's do it this way now. We take the tangent of 64, and we'll just use our calculator for that. You want to make sure your calculator's in degree mode. That's going to be equal to x over 11. So I'm going to go to my calculator to take the tangent of 64 degrees. You want to make sure your calculator's in degree mode. If it's not, you'll get a weird answer. So if you don't get the same answer as me, you want to change your mode to degree mode. So when I take the tangent of 64, I get 2.05. So what happens now, we have tangent of 64 equals x that I'm looking for over 11. Well, we just plugged this in the calculator and found that it's 2.05. So how do I solve this for x? I multiply both sides by 11. So 11 cancels out on this side, my solution will just be 11 times 2.05. So 11 times 2.05 is 22.55. So let's see what we have in the next one. Next one we are involving the 29-degree angle, and now we have x, which happens to be adjacent to it. So we have an adjacent side, and we have 29, which is the hypotenuse. So we have AH, which would indicate we're going to use cosine. So I want to take the cosine of 29, set that equal to the adjacent side x over the hypotenuse 29. Right? The hypotenuse is 29, x is the adjacent side. So I'm going to need my calculator to get cosine of 29. So when I do cosine 29, if you're using the calculators we had in class, the TI-34, you're going to have to hit the second button and the pi key. You'll see trig above that, and you'll see your sine cosine tangent there. But I hit cosine 29, and it's 0.875. Your computer probably has a scientific calculator app on it anyway. Equals x over 29. So again, now to solve for x, I would multiply both sides by 29. So I'm going to have 0.875 times 29. Right? If I multiply by 29 on this side, the 29's divide out. And then we multiply by 29 over here, and that is our solution for x. Okay? So 0.875 times 29, I get 25.36. So just watch the rounding. If you ask for one decimal place, that's 25.4, or to 2, it's 25.36. And the last one here, let's look at where our angle is. It's 41, right here. We're looking for x, which is adjacent to it, and we also have the hypotenuse. So it looks like we're dealing with a similar situation to what we just had, with the adjacent side and the hypotenuse to that angle. So we're going to want to use cosine. So I'm going to take the cosine of 41, and I set that equal to the adjacent side, which is x, over the hypotenuse, which is 32. So I take the cosine of 41 on my calculator, and I get 0.755. So that's going to be equal to x over 32. And now I multiply both sides by 32. So my solution for x, so 32 over here, they will divide out, and x is just going to be 32 times 0.755. And I get 24.15. Okay? So make sure you answer the questions below in our Go Formative.